Welcome back. We're in section 2.4, that is equations with absolute values. So before we get into the equations, let's take a look at concept here. The absolute value of a number, let's say the absolute value of a number is a positive value expressing the kind of the idea of distance. The measure of how far away it is from that number is from zero. So on a number line, we have 0, the number, say 3, is 3 units away from 0. The number -3 is also 3 units away from 0, just in the other direction. The absolute value disregards what direction you're talking about and just returns a simple positive value that expresses how far away you are from 0, right? And that is to say the absolute value is represented by two straight lines around the number. So let's say I have, maybe 5. This says the absolute value of 5. And that, of course, is 5, right? Whenever you take the absolute value of a positive number, it stays positive, nothing changes here. If I take the absolute value of -5, that is 5. It's the positive distance, how far this number is from 0, disregarding the direction, right? So if I have an unknown value inside my absolute values, right? And let's say we have the absolute value of this unknown number is 5. Right? Well, there's two values in here. It could be either 5, because the absolute value of 5 is 5, or it could be the -5, because the absolute value of -5 is also 5, right? So this key concept right here is that this equation breaks down to two possibilities. Possibility 1 is that whatever's inside the absolute values is the positive value, or it could be, and this is an or, that whatever's inside the absolute values could be that negative value, right? And that's what we're going to do every time we see an absolute value equation, is break it into the two cases. Whatever's inside here, unchanged, is either the positive or negative of the opposite side. Okay? So let's take a look at a couple of questions dealing with this. Let's say we have let's go simple. Well, let's not go simple. Let's go x plus 3 equals 12. Now the idea was that whatever's inside this absolute value is either 12 or it's -12. So when I write my two equations, this x plus 3 needs to be unchanged, right? So it's x plus 3 still. I don't change the x plus 3. Then x plus 3 is either equal to 12, because if it were, the absolute value of 12 is 12. Or then x plus 3 is -12, because if x plus 3 is -12, then this absolute value of -12 is -12. And so I get those two statements. Notice the only difference between these two equations is the 12 and the -12, right? That right-hand side is either positive or negative. And then I solve, right? Each one of these, I can subtract 3 on the left equation to get me x is equal to 9. Or, if I subtract 3 over here, we get x is equal to negative 15. And you can check these, right? I can make sure that these are correct. The absolute value of x, which I'm saying is 9 plus 3, is equal to 12. That's true. 9 plus 3 is 12, and the absolute value of 12 is indeed 12. Right? That one checks out. The other one, if x is negative 15, that gives me the absolute value of negative 15 plus 3 should equal 12. But negative 15 plus 3 is negative 12. And look at that. The absolute value of negative 12 is indeed 12. So they both check out. Right? So we're good there. Okay. Sometimes there's more stuff hanging around, right? We might end up with something like this, perhaps. There's a 4 plus that absolute value expression equals 16. Now what I always want to do before I try to break this into two equations is to isolate that absolute value. So that's our key, is to isolate the absolute value expression. Before I break it into two. Because if I break it into two, I'm going to mess it up because there's some stuff hanging out over here that will mess up my equation. So what I want to do is treat this whole absolute value expression right here like its own little mathematical term and just get everything else away from it. And I can do that by subtracting 4. I still have the addition principles, the multiplication principles, right? If I subtract 4, I'm left with just the absolute value expression of x minus 2 inside the absolute values equals 12. Now that I have the absolute value isolated equals a number, I can break it into two equations. Either x minus 2, once again, whatever's inside here stays unchanged, is either 12, or it is, that x minus 2 again, unchanged, is negative 12, right? Add 2, and I get 14. Add 2, and I get x equals negative 10. Right? I'll leave you to check that one, just plug it into here, right? I mean, you can kind of do it, sometimes you can do it by visual. 14 minus 2 is 12. The absolute value of 12 is 12 plus 4 is indeed 16. So 14 works out. If I throw in negative 10, well, negative 10 minus 2 is negative 12. The absolute value of negative 12 is a 12 plus 4 is 16. Right? So I ran through those pretty quickly, but take a minute if you don't see it right off the bat and plug them in and try them. Make sure that they do work. Now, speaking of isolating the absolute value, sometimes they get even a little bit more hairy. Let's take a look at something like, say, this one. In fact, what I want to do, maybe I'll make it even a little bit uglier. I think this one a little bit, right? So the idea here is I want to isolate the absolute value expression, and again I'm going to treat this absolute value expression like its own little mathematical entity, right? Pretend it's just an x, right? 2 minus 3 and some big x, or a y, or a w, whatever you want to do. Just pretend that this is its own little thing that doesn't get touched, right? Until it's isolated. This is 2 minus 3 times this whole thing, so remember your order of operations, right? That old PEMDAS, if I can spell. Where you do parentheses, exponents, multiplication and division, left to right as you see it, addition and subtraction. So I can't take 2 minus 3, right? Don't do that, that's wrong, right? Because this 3 is multiplied by this junk. That would be like saying I have 2 minus 3y, and I'm just going to take 2 minus 3 and call this negative y. No, you're not, right? It'll be wrong, guarantee it, it's going to not work out very well, right? But what I want to do is if I had this 2 minus 3y equals whatever I had, right? I would start with the addition principle, get rid of the 2, then the division, and work my way that way. And that's what I'll do here. I want to get rid of this 2, so I'll subtract my 2. Right? That's gone, and that still leaves me with a negative 3 being multiplied in front of the absolute value expression here. 41 minus 2 is 39. I'm sorry, this is not going to work out. I apologize. I'm going to change this to be a negative 37. We're not ready for what's about to happen here, so let's not walk down that road until the next problem. Negative 37 minus 2 gives me negative 39. That's what I want there for now, right? And I still want to isolate this absolute value. And I have this negative 3 being multiplied by it, so I get rid of something that's being multiplied by dividing. That 3 cancels, the negative cancels, I end up with the absolute value of x minus 2 is equal to, and now it's a positive, and so that's 13, right? You'll see why I changed this in the next one because, well, you'll see. I'm not going to ruin it now. But now I'm ready to break this into 2 equations, right? This tells me that either x minus 2 is 13, or x minus 2 is negative 13. And I just have to add 2. That gives me x equals 15. Add 2 over here. Gives me x equals negative 11. And that's it, and I'm done. And those are my 2 solutions. Now let's do one that was going to be created with the original problem that I wrote. Let's take a look at that. If I have, let's say, the absolute value, I'm going to go super simple here. The absolute value of x equals negative 2. What could possibly solve that? Well, if you think that x is 2, maybe, but the absolute value of 2 is 2, not negative 2. And so think, oh, well, maybe it could be negative 2, but the absolute value of negative 2 is also 2, and it's not negative 2. So neither of these are solutions, right? And in fact, by the very definition of absolute value, that absolute value is always a positive number. And at worst, 0, right? Because if I have the absolute value of 0, 0 is 0 units away from 0. But I'll never get a negative on the right-hand side here. The absolute value can be at minimum 0. Anything else that goes in here is going to give me a positive number, right? So this has no solutions. Right? If you have the absolute value of something equals negative, nope, it's not going to work out. Because, again, by definition, those absolute values are always non-negative, specifically they're positive or potentially 0. Right? And that's what we would have run into in that problem. That might look something like this. Right? Does this have a solution? It looks like it until you start getting into it. Right? I'm going to isolate this absolute value by subtracting 10. If I subtract 10, then that gives me 2 times the absolute value of x plus 5, equals -2. That might be an issue. Let's completely isolate, and you can probably see it. Yes, it's going to be an issue, but let's completely isolate the absolute value before we make that decision, and I'll show you why in a minute. I have absolute value completely isolated is equal to -1, and I know no matter what x is, I will never get a negative out of this, and so I'm done. I stop there. I don't break it up into two equations, because if I do, I can work it out and get answers. Those answers will just be wrong, right? And so I'm done. There is no solution here. Okay, this one perhaps. Again, the very first thing that I want to do is get rid of this 18. So I'm going to subtract 18 from both sides. That leaves me with this -3 in front of the absolute values. X plus 5 equals -15. And you might think, oh, there's a negative over there. I'm done. No, you're not, because there's a negative over here as well, right? And if I continue and completely isolate the absolute value by dividing by -3, in fact, the negatives kill each other, and I can solve this, right? There's solutions to this. So I break it up into the two equations. That x plus 5 inside the absolute value is either equal to 5, or that x plus 5 is equal to -5. Right? Subtract 5 to get x equals 0, or subtract 5 to get x equals -10. And done. Alright. Good. And then there's one last type. That covers most of them that you'll see. There is one last type. I mean, there's more, but they get so hairy that we stop pretending that we can do much with them. So the last type that we can really work with for now is if I have two absolute values. The absolute value of one expression is equal to the absolute value of the other expression, right? So if I simplify this just a little bit, let's take a look at maybe the absolute value of x is equal to the absolute value of y, right? So we'll ignore this problem just for a minute. The absolute value of something is equal to the absolute value of the other thing. There's two scenarios here. Either those two things are the same, or they're opposite. Right? And really there's, if you want to think about it this way, there's four cases. You could have x equals y, or the opposite value of x is the same as the opposite value of y, but this is redundant. That's the same thing as that. So I'm not going to go through and do this third equation. The other equation is that, well, maybe it's -x equals y. But I think you can see if you just multiply both sides by -1, you get the same thing back. And so I don't need to do that. I only have two cases, right? And that's basically it. They're either the same number or the opposite, and I take care of the opposite with this equation. Right? So that means that I can turn this into those two equations. And I'll do so by saying that either 3x plus 1 is the same thing as 2x minus 5, or that 3x plus 1 is equal to the opposite of 2x minus 5. So if you think about the opposite, I have this 2x minus 5. Calling it the opposite is taking a negative in front of everything, so that distributes to give me -2x plus 5. So what's the distribution there? The negative goes through every term. So you get negative 2x plus 5, and those are my two equations. And then I just have to solve them, each of them individually. I'm going to take my 2x to the left on this left equation by subtracting 2x from both sides and simultaneously subtracting 1 to get the constant term out of the left. This one finishes up nicely with x equals negative 6, and I'm done, right? And I can check that. Before anything I do that one, I can check this. Negative 6 plus 1, let's do the whole thing, equals 2 times negative 6 minus 5, right? That's negative 18 plus 1. That's negative 12 minus 5. You can see, I'm kind of running out of board space here, but you can see both of these are going to end up with a negative 17 in the inside. The absolute value of negative 17 is equal to the absolute value of negative 17, and we're done with that one. Right? The other one, again, I just simplify or solve. I'm going to go with add 2x to both sides. Subtract the 1 from both sides. This gives me 5x equals 4. And then just divide your 5. We have x equals 4/5. So I have two solutions, once again. Alright, that'll do it for this section, and I'll see you in the next.